In this lesson, we're going to solve two-step equations. So how do I solve two-step equations? Solve the equation and then check your solution. So for number one, we have 3x minus 7 is equal to 8. So the first thing we want to do is we want to draw our line down, and we're going to be isolating the variable. All the numbers with the variable will go to one side, and the numbers without the variable will go to the other side. So when we're solving equations, we are undoing the order of operations. And so the order of operations, please excuse my dear Aunt Sally. We had the parentheses, the exponents, the multiplication and division from left to right, and then the addition and subtraction from left to right. And so when we're solving these equations and we're undoing the order of operations, we would have to start by undoing the addition or subtraction. So when applying the properties of equality to isolate the variable, I also like to think about this as we're undoing the things around the variable. And this minus 7 is further away than the 3 because the 3 is touching it. So I'm going to undo that minus 7 by adding a 7. And when I add the 7, I have to do what I do to one side, I have to do to the other. So now I have 3x is equal to 15. And now that 3 is multiplying the variable. And so to undo multiplication, we're going to divide, and x is going to be equal to 5. All right, so let's go ahead and check our solution. So if we're saying that x is equal to 5, we have 3, and then x, which would be 5, and the number right next to the variable is multiplying, minus 7, and is that equal to 8? Well, we have 15 minus 7. Well, 15 minus 7 is 8, and 8 is equal to 8, so we know that we have the correct answer. All right, let's start with our next one. We have x divided by 4 minus 3 is equal to 5. All right, so again, we're isolating the variable. We want all the variables to one side and all the numbers without the variables on the other side. And so we're going to ask ourselves, well, what is that 3 doing to that variable? And it's minusing. And remember, to undo minus or subtraction, we're going to add 3 to both sides. So now I have x divided by 4 is equal to 8. Now we're going to look at this variable, and what is a 4 doing to the variable? Well, the 4 is dividing, and to undo division, we're going to multiply. So on both sides, we're going to multiply by 4, and that's going to cancel out the 4's, and then x will be equal to 32. All right, so let's go ahead and check our answer. So we're saying that x is 32, so we're going to plug in the 32 for x. So we'll have 32 divided by 4 minus 3, and is that equal to 5? Well, 32 divided by 4 is 8, and 8 minus 3 is equal to 5. And so once we plug that in, we know that we have the correct answer. All right, question number 3. We have 2/3 x plus 5 is equal to 25. Again, let's draw our line down, and we're going to ask ourselves, well, what is that 5 doing to the variable? Well, since it's adding, we are going to undo it by doing the opposite. And the opposite of plus is minus. So I'm going to subtract 5 on both sides. And now we have 2/3 x is equal to 20. All right, so we did some of these last week. We have 2/3 x. So the 2/3 is multiplying that variable. To undo multiplication, we divide, and dividing a fraction is the same thing as multiplying by its reciprocal. So I'm going to multiply by 3 over 2 on one side, and what I do to one side, I have to do to the other. All right, so these all cancel out, and I'm just going to make those both fractions. So we have x, and then 3 times 20 is 60, and then 2 times 1 is 2. We can leave this as 60 all over 2, or we can divide it and we would have 30. All right, so question number 4, we have 10 is equal to negative 3x minus 8. So again, we're isolating the variable by drawing our line down, and we're going to undo the things that are further away from the variable first, or we're undoing the order of operations, which would say to undo the addition or subtraction first. And so since I have a minus 8, to cancel out a minus 8, I would add 8. And what you do to one side, you have to do to the other. You'd have 18 is equal to negative 3x. And so now looking at, we have negative 3 is multiplying the x. To undo multiplication, we're going to divide. So x will be equal to negative 6. And let's just go ahead and check this one. So we have 10 is equal to negative 3 times negative 6 minus 8. So 10 is equal to, we have negative 3 times negative 6 is 18. And is 18 minus 8 equal to 10? Yep. And once we've checked it, we know that we've done it correct. Number 5, we have 1/2 x minus 3 is equal to 4. All right, so again, we're going to be isolating the variable. And to undo a minus 3, we'd add 3. And what we do to one side, we have to do to the other. So 1/2 x is equal to 7. Now, the other ones that we have been doing, because they were like, believe the last one was what, 2/3? That's going to be a repeating decimal. It goes on and on and on. Well, if you have a decimal like 1/2, certainly we could say, well, the 1/2 is multiplying the x. So we could then, to undo multiplication, we divide. And dividing a fraction is the same thing as multiplying by its reciprocal. So we could multiply by 2 on both sides. Or, all right, so there's a couple of different ways you could solve the rest of this. So the 1/2 is multiplying the x. And remember, to undo multiplication, we divide. And then dividing a fraction is the same thing as multiplying by its reciprocal. So I could multiply by 2 on both sides. That cancels out that. And x would be equal to then 14. I could also, I'm going to rewrite that 1/2 x is equal to 7. I could also take this fraction because this is not going to be a repeating decimal for this one. And so I might decide to just turn it into a decimal right off the bat. So I could say, well, 1/2 is equal to 0.5x. And that makes it pretty easy to be able to then just divide by 0.5 on both sides. And we would have x is equal to 14. So either way, you could either just multiply by the reciprocal, or in this case, you could also just turn this into a decimal. All right, question number 6. We have 5 minus 3x is equal to 14. We need to be careful with ones like this. I find that a lot of people make mistakes on them because what they're looking at is a lot of times they're looking at that 5 as a negative 5. But this negative right here, it belongs to the 3. That 5 is a positive 5. And so again, we're isolating the variable by undoing the things around it. So I'm going to start by undoing that 5 by minusing that positive 5. And remember, what you do to one side, you have to do to the other. All right, so what's that negative 3 doing to the variable? Well, it's multiplying. To undo multiplication, we're going to divide. And x then will be equal to negative 3. All right, question number 7. We have 4 minus x is equal to 12. All right, so looking at this one, we're isolating the variable. And again, that's a positive 4. That minus belongs to that x. In fact, what I'd probably do is come right here and put a 1 right there. And so I'm going to take and I'm going to minus 4 on both sides. So 12 minus 4 is 8. And so now what's that -1 doing to the variable? It's multiplying. And then to undo multiplication, we're going to divide. And x is going to be equal to -8. All right, for question number 8, I'd like you to pause the video. I would like you to solve this one, and then we're going to come back and we'll check it when you're done. All right, so taking a look at this one, to undo that +2, we minus 2 from both sides. And make sure -6 minus 2, you're 6 in the hole, you go another 2 in the hole, you have -8. And then we have 8x is equal to -8. And the 8 is multiplying, so we're going to divide. And then we'll have x is equal to -1. All right, so for this next one, I'd like for you to pause the video. I'd like for you to try it. I'm going to just give you a hint here, and I would probably put a 1 right here next to that -x. So go ahead and solve this one, and then come back and let's check it. All right, so we had -2 minus x, or minus 1x minus 3. All right, so we're going to undo the numbers without the variables first. So we're going to add a 3 to both sides. And -2 plus 3 is equal to 1. And then we have a -1 that's multiplying that variable. So we're going to divide both sides by -1. And hopefully you got x is equal to -1. All right, question number 10, you have 9x all over 10 plus 3 is equal to -1. Boy, there's a couple of different ways you could do this one. First of all, let's start by isolating the variable by undoing that 3. So I'm going to minus this 3 on both sides. Let's see, 9x all over 10 is equal to -4. All right, so let's just look at these a couple different ways. Let's start with this one by just isolating the variable and saying, well, what is that 10 doing to the variable? Well, the 10 is dividing, and so to undo division, we would multiply. So I could multiply by 10 on both sides. And then I'm going to divide by 9. And since I can't divide -40 divided by 9 evenly, I'm just going to leave that as a fraction. All right, so let's go back up to that 9 all over 10x. So when you've got this 9x all over 10, it's the same thing as 9 all over 10x is equal to 4. So, or I'm sorry, -4. So we could look at this as, well, the 9/10 is multiplying the variable. To undo multiplication, we divide, and dividing a fraction is the same thing as multiplying by the reciprocal. So we could multiply by 10 all over 9. These all cancel out. And you would have, again, -40 all over 9. Since we've already done a couple, like number 11, we're going to skip that. We're going to do number 12. I would like for you to pause the video for you to do this one by yourself, and then we're going to check it and before we're all done. All right, so we had x divided by 2 plus 4 is equal to 6. So we isolated the variable by first subtracting the 4 on both sides. And then we got x divided by 2 is equal to 2. Well, that x is being divided by the 2, so we would multiply by 2 on both sides. And then these cancel out, and x is equal to then 4. So in this lesson, we took a look at how to solve two-step equations.